Welcome everyone. Thanks for being here. My name is Sigi and I'm from International Timberframes in Golden. I heard there's going to be lots of people here today, so I'm feeling a little bit nervous. So hopefully I'm not going to get too flustered during this presentation. Our mission is to inspire North America to build with natural solid wood so that we can build healthy and sustainable homes that last for generations or even centuries. We worked together with the Urban Arts Architecture in 2017 to build the Radium Community Center, and to my knowledge, that was the first commercial DLT project in Canada or even North America. We manufacture DLT panels here in Golden since 2017. We are passionate about building with natural solid wood, and today I will be talking about Dowel Laminated Timber. You cannot have missed the massive focus on massive timber in BC and Canada in the last few years. Dowel Laminated Timber is just one type of the mass timber product, and we believe it's the healthiest, most sustainable mass timber application. The focus for DLT seems to be mostly in multi-story buildings, but we know the benefits also apply to single-family homes and smaller workspaces. As Rory noticed, I was part of a team in the 1990s in Switzerland that developed a Dowel Laminated Timber product. So the product is not new. There are lots of research and learnings from Europe that we can use here in Canada. And I'm really excited to see that Dowel Laminated Timber is now being recognized here and people start using it. I look forward to sharing my knowledge with you guys today. So here is the plan for the next 45 minutes. I will start by talking briefly about what DLT is, how it's made, and the different types and different applications. After introducing some of the structural considerations, we'll focus on what I think are the three key benefits of DLT over other mass timber products. Those are health, sustainability, and energy efficiency. Then I talk a little about design flexibility and working together with DLT manufacturer. We will spend time on questions and answers at the end, so please just put your questions into the chat and then we can deal with them. I really could speak for hours about DLT, and so cutting it to 45 minutes will be a challenge. Forgive me to starting with the basics, and most of you may already know, but just to recap, Dowel Laminated Timber is just a type of mass timber. Mass timber uses state-of-the-art technology to connect layers of wood pieces together, using either glue for glue lam on CLT, nails for nail lam, or NLT, or wooden dowels for DLT. The resulting large structural panels are exceptionally strong and versatile and collectively known as mass timber. DLT is a mechanically connected wood product within the range of mass timber. And this is how it's made. Layers of softwood lumber are put together, a hole is drilled through the assembly, and the wooden dowel is put through that hole. There's no glue, no nails, just the wooden dowel. The wood boards have a moisture content between 10 and 15%, and the dowels are bone dry. So as soon the dowel is inserted into the hole and is connected in contact with the surrounding wood, it will absorb the moisture from the surrounding wood and it will expand. This forms a mechanical connection that is incredibly strong. Crucially, for some of the benefits I will talk about later, it is glue-free. Not all DLT is completely glue-free, ours is. But you should always ask, some manufacturers will use a little bit of glue in their production. Crucially, there are two types of DLT. You can have stacked and crossed DLT. Let me explain. Stacked DLT. This is what most people think of as DLT. We call it stacked DLT from the translation of the German word Brettstapel. This is the product we mostly produce here in Golden. Layers of lumber are stacked together side by side on their edge and are connected with the wooden dowels. The surface appearance can be different, so you can have a flat panel, or you can have a fluted panel where you could use 2x4 and 2x6 in a staggered setup, or 2x6 and 2x8. These large panels are very often used in ceiling and roofs, as we did at the community center in Radium. Cross-laminated or cross-DLT. This is the type of DLT most people don't really know about yet. In cross-laminated DLT, the large size panels are manufactured by laminating 3 to 11 layers of softwood lumber. The panels are made by layering wood on top of each other on their flat side at alternating angles, and then a hole is drilled through it and the pack is inserted in the hole, as is done with the stacked DLT. I also like to point out that we like to optimize as early on. As you can see in the picture, windows and doors are left open to optimize material use. Not like glued CLT that produces large format sheets and then the windows and doors openings are cut out. In that case, these offcuts become contaminated waste, and I'm not quite sure what they do with it all. We produce both the stacked and crossed DLT here in Golden, and we call it Wood 100, as it is 100% wood. Rory, is there any questions about DLT and how it's made so far?
No, not yet, Sigi.
Okay. In general, both of the types can be used for all application purposes in a house. You can use them for walls, floors, and roofs. However, there are important differences between the two in terms of applications and performance. Stacked DLT has higher structural values for ceilings and roofs in a single span application, and cross-laminated DLT has higher structural values for shear walls and for seismic zones. I will talk later more about other reasons to use stacked versus crossed. For example, cross-laminated DLT offers superior thermal insulation over stacked DLT, NLT, or glulam. It has almost the double the R value of any other solid wood products. Sometimes it's a different aesthetic of each product that drives the choice of which one is used. You can clearly see the different appearances when stacked or cross DLT on the pictures on the slides here. On the top left, you can see the single span stacked DLT in two different appearances, the flat surface on the outside and the fluted on the inside. On the bottom left, you clearly see the primary structure with glulam and the secondary structural panels with fluted stacked DLT. Both of those pictures on the right and the left are from the Radium Community Center. On the middle picture, you can see that the walls and ceilings are with the cross-laminated DLT. And on the right, it is a combination of crossed DLT on the walls and stacked DLT on the floor and on the roof. This is actually a sauna that we are building at our shop at the moment. We work together with structural engineers and can perform all the structural analysis if needed. Structural benefits of cross-laminated DLT are that pretty much every wall can be used as a shear wall with because of the diagonal layer within the panel. Since we only use standard lumber for our panels and don't do any finger jointing, we have a few restrictions because of that. So regular lumber just comes up to 20-foot spans. So 20 foot is a maximum length. We can go up to 24 feet if necessary. And commonly in mass timber, a 12 to 16 foot grid is the most economical and structurally efficient grid distance anyway. So with our panels, that we can easily accomplish that. Cross DLT are used for shear walls and stacked for single span applications, and we saw those ones in the pictures before. Fire protection and seismic considerations are also important. I will talk about that a little bit next. So wood and fire has a predictable behavior. They call it the char rate, and it's 0.7 millimeter per minute. So that relates to roughly 1.5 inches per hour. In this picture, you can see a cross-laminated DLT panel that was used for the fire testing. In this case, they put the test on for 135 minutes, so over 2 hours. And within those 2 and a bit hours, the panel burned off almost 4 inches off the bottom layers. Because this panel was over 12 inches thick, it was still structural at this point after a 2-hour fire exposure. The interesting part here is that we have the fire exposure with roughly 1,000 degrees on the bottom, but the top surface of that floor only increased by 2 degrees. So you could literally walk on that floor barefoot after a 2-hour burn below. The other thing is too with the Dowel DLT, you not have any extra fumes that gonna be released, especially from glues that can create really toxic gases.
Hey, Sigi, I have some questions here for you.
Okay.
So the first one, so this will relate actually back to the beginning. Is the dowel spacing, is the dowel spacing varies the structural strength of the panel? So does the dowel spacing vary the structural strength?
The dowel spacing in the stacked DLT is not really, the dowel is not considered as a structural entity. In the cross-laminated, it definitely has an impact.
Okay, excellent, thank you. And how big can you make your DLT panels?
Like what we are doing right now, we do a billet that is at the moment it's 16 inches wide by 20 or 24 feet long, and then we pre-assemble those billets into 4 foot 8 or 8 foot wide panels.
Okay, perfect. What is the minimum grade of lumber used in your panels?
We have used mostly number 2, but we use we do use higher grades of that in different applications, and I will mention that here further on in the presentation.
Perfect. Can beams be made with vertical joints and horizontal dowels, like a dual lam or tri-lam?
Beams we have, I guess technically they could be done as long the beams are not more than 12-inch tall, because that's all we can get for dimensional lumber in height. Okay. And then it would be pretty much like a built-up beam, but I'm not sure if there's actually anything released in the code for that.
I think this one, I think they're alluding to more of like a CLT configuration with vertical and horizontal, or vertical joints and horizontal dowels. Okay, no, I think you got it.
Okay.
And,
okay. Yeah, same thing. Rory, maybe with the questions, maybe if we can just maybe keep it to one question within the section, and then wait for the rest in the end, because otherwise I may not be able to get through my presentation here.
Fair enough.
And I will have more time after the presentation in case we're gonna get too long.
You bet. You bet.
Okay.
So go ahead.
Okay, so here fire, let's just keep going on the fire here. Not in all cases we actually need sprinklers. So in radium, actually the DLT sealing was done without sprinklers because there is in the BC building code, there is a heavy timber section where if the sizes of the timbers are certain exceeding a certain size, it can actually be done as a heavy timber in a combustible construction. So if we would do the same test, what happened to that piece of wood with concrete, that's how the concrete actually would look after 2 hours of full burn. The concrete, reinforced concrete would just crumble away on the bottom. The rebar is start melting and bending, and you wouldn't be able to walk on top of the ceiling or on that floor because that would be hundreds of degrees hot. Seismic is definitely a point that is discussed a lot. I know that some European manufacturers have been exporting cross-laminated DLT to Japan and got the highest earthquake rating for their buildings. And some of those buildings, or all of those buildings, survive the earthquakes that are happening frequently down there. There is also a DLT producer in Japan now, and that also goes well with their tradition. They have some of the oldest buildings in the world that are only made out of solid wood and wooden dowels. So DLT will also go along with their tradition. So any burning question about fire and earthquake?
No.
Okay. Okay, now we look at the key benefits of DLT, in my opinion. All types of mass timber have benefits over other building methods. Speed of construction due to prefabrication, for example. But DLT has benefits over other mass timber products like glulam, NLT, and CLT. This is the reason why we produce only 100% wood DLT. The three benefits are health, sustainability, and energy efficiency. Let me start with the health benefits of DLT compared with other mass timber products and timber building systems. I'm sure you know already that many studies have been made about biophilic design, and it has been found to support cognitive functions, physical health, and psychological well-being. No wonder we should be all surrounded by natural solid wood. Here are maybe a few facts that are new for you. We know off-gassing from glues or contamination from chemicals, 100% wood DLT offers a significant healthier indoor environment, particularly for those with allergies and hypersensitivity. A lot of people say that glues are now formaldehyde-free, what is true, but formaldehyde is was just replaced with another toxic component. So as long we don't have any better scientific proof that those ones are good or bad for us, the formaldehyde-free is still the main reason they say it's good for you, even using wood with glue. Different layers of different materials with different characteristics can create issues with moisture management. In terms of building physics, DLT walls consist of just one thick block of layered wood, a wood-only monomaterial wall. There are therefore no changes in the vapor permeability within the wall, and no moisture can be condensed on vapor barriers, foils, insulation materials, and other layers within that buildup. 100% wood DLT regulates the indoor climate much better because moisture can freely be transferred between the whole wall system. Also, radiation shielding. There is extensive research done in Europe that wall thickness over 10 inches can shield radiation, high frequency radiation up to 99%. Even the German defense has built some bug-proof buildings in DLT to avoid spies listening into their conversations. So these are just some of the key health benefits. I'm sure there's many more, and I could just go on for a while, but we just need to move on here. Sustainability. Construction is a major contributor to waste, and everybody in the industry needs to be more responsible in the products we are leaving behind for future generations to manage, live with, and dispose of. Our 100% wood 100 DLT is completely clean, truly cradle to cradle, and contains no glues or other chemicals, making it 100% uncontaminated and therefore 100% recyclable wood product. It can be disassembled and reused, burned, or composted at the end of the life. Locally produced, we can also use lower quality material for the hidden layers, and we can also use undervalued species. We are proud to make 100% wood, 100% reusable, and 100% recyclable product. This is one of the oldest houses in Switzerland, dated in the late 1280s. There is about 20 of these kinds of houses in the same region, and most of them are still inhabited now, after over 700 years. And there is many buildings from the 15th to the 18th century all over Switzerland that are used on a daily basis. As you can also see, there's no stain and paint on this house, and the wood is still intact. So it is not the stain that protects wood, it's the constructive details like big overhangs, protection of moisture, that make sure that wood can last that long. Smart details for wooden structures is another topic that I could actually fill a whole webinar with as well. So this building is a log building, so comparable, a lower tech construction method than DLT. And with all the experience and scientific advancement we have, we should be able to reconstruct building that lasts at least 100 years or many 100 years. And we will also need to reassess the life cycle assessments and how we measure those ones. Basing them at 30 years, I think doesn't make justice of a product that can last hundreds of years. Now I want to go back to the cross-laminated DLT and its superior value in energy efficiency, or the R value. So with the layers not being glued together, there's small little air pockets, and there's many tests in Europe suggest that the R value is pretty much double than that of solid wood. Here is a hot pot test that has been done in Austria, I think 10 or 15 years ago. And the way they tested 3 different wall assemblies. One was a passive house wall, one was a brick wall with styrofoam insulation, and the other one was a solid wood wall with wood fiber insulation. They all had a similar R value between R36 and R38. So they heated up those wall assemblies and to 21 degrees, and then dropped the outside temperature to -10, and measured how long it will take for the cold to creep to that wall and until the inside surface is 0 degrees. So the passive house stick frame wall was frozen on the inside after 41 hours, so literally just 2 days. The brick wall with the styrofoam insulation took 259 hours, a little bit over a week. And the solid wood wall with the wood fiber insulation took 770 hours, so over a month. So even though they had the same R value, those differences were enormous. So that's a point I try to make all the time, that R value and energy efficiency is not equal. And we are actually in the process to get some test samples ready to make some testing in Ottawa, some hot box testing to prove similar results with our walls, to make sure that we have some test results from a Canadian institute. So this house was built with those test results in mind. This is a 5-story building in Switzerland, 1,000 meter above sea level, and there's no heating system in this house. This whole house is only heated with passive solar. They have a rammed air earth floor that acts as a short-term storage for the heat, and then when that got released, then the solid wood wall will absorb that heat and store it for even longer. This house had a 12-inch thick solid wood wall with 3-inch wood fiberboard insulation, and then a rain screen and wooden siding. Also on this siding, you can see there's no paint on the siding. The owner also did a temperature testing during the. Sorry.
Oh, sorry, Sigi. No, I was just talking to Jerry inside. Forgot I was.
So yeah, here you can see the measurements that happened inside and outside. On the bottom, you see the temperature in February dipped just below -10. And the red line above in the yellow bar shows the inside temperature. According to the calculations, they were hoping to keep the temperature between 18 and 24 degrees. And you can see there's a couple of times where the temperature dipped below that for a short little period. The owner told me that this was not a reason to put a heating system in there, because it's simple enough to just have a fondue party with some friends, and the temperature will be up again. So are there any questions about health, sustainability, or energy efficiency?
Yeah, just a second here.
Maybe just one or two, and then we can.
I guess required. We'll get that one after. So there was a question here that says, I do not see vapor or air barrier plus air changes and control of humidity level must be a concern. How are those addressed?
There's no concern. It's like a log building. You don't need any vapor barriers in log buildings as well. And that's the beauty with the mono material. There is just natural humidity that is regulated by the wood. And they actually did some studies in Austria where they tested the indoor air humidity, and they found even in really dry and cold winters, the moisture content in the indoor air never fell below 45%. And because the moisture gets actually released from the wood wall into the interior, the wood wall actually dries up and actually increases the R value of the wall. So I guess it's just a wood as a natural material with these phenomenal characteristics.
Excellent. And we'll do one more here and then we'll continue on. So how do you restore burnt DLT after a fire, assuming that the structure is still valid?
Yeah, I'm luckily where I haven't have to deal with that before, and I don't have an answer for that at this point. So I'm not sure if you could just with maybe with sandblasting or something like that restore it. And I think it would also depend if this is actually something that will be accepted by a building inspector. So I'm not quite sure what the legal implication would be here for that.
Okay. We're going to take a third question here. It's going to be a follow-up to the moisture question. So Tim had asked about the moisture question, and to follow that up, it's like, what about cooking, bathing, showering, and laundry, adding moisture into the building?
I will actually have a slide coming up here later on, and I will talk about that later on.
Perfect. Okay.
Okay.
Let's continue on.
So the design for DLT buildings is flexible and has no architectural restrictions. It can range from office cube in a garden to multi-story buildings, and it can be finished with stucco on the outside or wood clad or other cladding materials. On the top right, you can see a multi-story hotel and spa, and on the bottom right, you can see a 4-story commercial center that was built in Austria in 2010 as a plus energy commercial building. This presentation is not about multi-story buildings, but I will mention a few more things about that hotel and spa and the upper right picture. This in the middle of the 2 wings, you can see the old original house or hotel they had there. And then on the right hand, they built a 4-story DLT wing with living quarter or bedrooms in there. This first edition was such a success that 3 years after, they built a 7-story building on the left-hand side. And on top of the 7 stories is actually a swimming pool. One of the most amazing facts or remarkable facts is that this is on a ski hill, and so the pasture in the front is actually the ski slopes, and the ski hill closed end of April, and construction started. And at the end of August, this whole hotel was fully occupied. Careful pre-planning and prefabrication made this possible to complete within 4 months. All the plumbing and electrical conduits were placed or were prepared. And so the trades only had to place the pipes and the installations. Panelization will reduce the time spent on site, but the total construction time will still be the same than conventional construction. The pre-planning and prefabrication time needs to be considered to make sure that clients don't have unrealistic expectations. I kind of break it down that conventional construction would be 20% design and 80% construction. And mass timber with prefabrication will need the same time span, only it will be 60% design and prefabrication and 40% on the construction side. Now we have a few sample pictures with from interiors. This is a kitchen living room or kitchen dining room where you can see the wall and ceiling with cross-laminated DLT. Here we have a bathroom, and you can see here in the bathroom you have a lot of exposed timber, and there's it's easy to be left exposed as long as there's not water splattering right onto the timber. You have such a big surface here that actually the wood will just absorb the moisture that happens during showering. And I talked to owners who said they had hardly any fogging up on their mirrors because the wood is just absorbing the moisture. And then also because it's untreated and left exposed, it can also release that moisture afterwards. So it's almost like a sponge that's takes the moisture on and then releases it, so it will actually equalize the moisture in the air. This is my favorite relaxation room, and this is actually in that multi-story spa that we saw earlier. And I was lucky enough to stay there for a few days and took full advantage of that room. So now I show a couple of projects that we have done here over the last few years, just to kind of give you a little bit an idea of what's possible. And as you can see, none of them are multi-story, they're all small spaces. This is an office workspace in Canmore, Alberta, and it's only 120 square foot. Same thing here, we do have a cross-laminated DLT on the wall and a stacked DLT on the ceiling. This is a ceiling for a bathroom in Coquitlam, and that's the most expensive DLT we ever produced. And you can see why, because there's only a few pieces that don't have a notch or a hole in it. So this is ended up to look like a Swiss cheese by the time it was done. And this one without insulation actually cost over $70 a square foot. So again, there it's when people ask for pricing, it's hard to give a price. It always depends on how it's going to look like. And this is definitely the craziest applications we use so far. This, on the other hand, was the most economical one we have done, and this was childcare in Salmon Arm. This is a typical hybrid solution, the kind of solution we provide in lots of cases. In this case, we had log posts, timber beams. We provided the design and supplied the metal knife plates and all the connectors, and also the DLT ceiling. In this case, the DLT was specified as a 2x6 number 2 DLT, and we were able to use MSR rated lumber, and because the maximum span was only a little bit over 11 feet, we could actually do it with a 2x4 rather than a 2x6. So this resulted in savings of material, and it also actually brought the cost below the lower grade 2x6 panel, and it was cheaper than doing conventional construction with tongue roof on the bottom and plywood on the top. This one, I think at the time in 2019 was roughly $18 a square foot. But yeah, I'm not quite sure how that would relate to the prices nowadays. Here, this is a little sauna we have in our shop right now. Same thing on the right bottom picture, you see we have cross-laminated DLT on the walls and stacked DLT on the ceiling. All the electrical and all the plumbing has been integrated. So this the sauna will be shipped modular, and the two metal brackets on the roof are strong enough to lift this unit onto the truck and off on the job site. And the little deck and the bench and the siding for the outside will be flat packed. This one is a little feature wall at the Radium outdoor skating rink, and we have done that after the Radium Community Center. Now I want to talk a little bit about DLT and what should be considered when you work with a DLT manufacturer. I use the Radium Community Center because that was for us was a great example how communication, collaboration, and teamwork can really help a project to be successful. We were early involved because the architects and engineers had an open house to see and find out what kind of woodworkers and trades are in the valley to actually be interested to work on this project. And that also the tendering was actually open tendering, so it was able to price out DLT options, CLT options, glue lime options, whatever, and in the end they just chose what worked out. The sawmill is literally 100 meters or 200 meters away from this building, so all the wood came right next to the building. The team-focused approach is really important, that the contractor, the manufacturer, and architecture are working together. We also did the BIM model for this project and made sure that everything was kind of coordinated to us, what happened on the job site. We also have a total station and went to the job site to measure out the foundation after it was poured, and realized pretty quickly that there was some stuff that was not quite according to the plan. But because we haven't cut any of the glue lam, it was easy to make adjustments. So in some cases, we just extended the post to the length they needed to be, and in some cases, the concrete foundation needed to be adjusted. And in the meantime, even before the foundation was poured, we were able to start the production on the DLT panels. The whole prefabrication process was not held up by that. On the other hand, the installation was a lot quicker because we didn't run into any issues, because by the time we went to the installation, we actually knew exactly what needs to happen. Also, the framer was a little bit worried that it's going to take way too long for him to wait until we have all our stuff up. But because we did the BIM, we could actually provide him with the plans for the walls. So they've pre-framed all the walls on the floor. And when we showed up, in times when we didn't need the crane, they were able to use the crane to lift up their wall panels in place, and had easy installation there too. It's crucial when you have prefabrication and multiple trades that it's clear where the overlaps are, and that everybody knows where one's job ends and the others begin, because that's where most of the times things are missed when the overlaps are not clearly defined. Our DLT panels were waterproofed when they arrived on the site, and we also did the roof in sections. So as soon we had our DLT in place, we installed the plywood, and then right behind was the roofing crew that actually put the roof on. So we were able to ensure that the building or the panels, as soon as they were up, they were waterproofed on at all times. And again, what I mentioned before, my opinion, the whole building time is the same, even prefabricated. It's just the times on site are cut shorter, where we have 20% in design in a conventional building and 80% on the job site, versus 60% design and pre-construction work and 40% on site. One thing that also I always want to mention is, please keep a budget for a BIM model. It will pay for itself if you have somebody in charge who combines all the information in one model, and everybody works off the same plan. Okay, here's the summary. There are two types of DLT. They're stacked and crossed. DLT has superior benefits over other building systems and even other mass timber products. Building with DLT, we can create the most sustainable and healthy homes that will last generations and hopefully centuries. There is no need to compromise comfort and energy efficiency when building with natural solid wood. Manage the expectation from the clients from the start, especially when using a prefabricated approach. Okay, I will open it up for question and answers here, and here's my email address. If any of you guys have any questions afterwards, please send me an email, and yeah, we're happy to discuss any DLT projects with you, as well as any other wood solutions, if it's timber frame or any solid wood products.
Excellent. Well, thank you so much, Sigi. And
You're
there are a host of questions here. So let's start at the top and work our way through it.
Mm-hmm.
What wood species and unique material properties are required for the dowels?
The dowels at the moment, we use a European beech, and it's just the characteristics of beech is that it expands the most. And so as it absorbs the surrounding moisture from the boards, it will expand quite fastly and create that mechanical connection. But said so, I'm also in contact with some companies to see if there's an option to use some Canadian species to use for DLT. But at this point, I'm not. I don't have any research or any answers on that.
Okay. So another comment slash question from Jared is, the one experience they have had with CLT involved treating the interior with a very toxic smelling stain. Are there finishes that you use on your DLT to avoid toxic off-gassing?
The best finish is no finish. I try to convince all my clients to use no finish. Like, and same thing with that sauna. There's no finish on the wood inside, and on the outside on the siding we use the burned approach to kind of pre-age the material. But same thing there. When you looked at that 700+ year old house, there's never been any stain on that house on the exterior. It has different colors, and some people just don't like the natural aging, so that's when they go to stain. But as soon you start staining, you have to stain all the time.
Right. Okay.
So out of that reason, I just say leave it alone.
Yeah. In the 5-story building that you spoke of, is the roof line thicker than the walls for more R value?
The roof on the 5-story building, the walls was an R38 on that one, and the roof was an R50, and that consisted, I think, out of an 8-inch DLT panel with most likely 10 inches of wood fiber insulation, something like that. Roughly.
Excellent. Okay, another comment question. So thank you for mentioning the air barrier and humidity considerations. Is the performance affected by a coating on the interior, such as a varnish?
Again, right, varnish. I try to convince people there is no need for varnish, right? As I said.
Okay.
It's wood has no issue with getting old. It's just kind of it starts looking older like we do, but other than that, it can last hundreds of years without any prevention. And the only thing is where it touches concrete or where it is exposed to moisture, we have to regulate that. But other than that,
excellent.
I would leave it natural.
That leads right into this next question. Do you know if there are any treated wood versions of panels used for below grade or foundation application?
I know they have built a DLT or a CLT basement in Switzerland as on a test scale right now. I'm not quite sure if it makes sense to treat the wood. I rather say just keep the water away from wood and you don't have to treat it.
Right. And can you use different species like Doug fir or cedar for exposed show surfaces on CLT, on your dowel CLT?
Yeah, yes, actually, and the samples I showed you were mostly Douglas fir, but again, it can be a combination that just the visible surface is a Douglas fir, and the hidden surfaces or the hidden layers behind can be a different species or lower grade. So yeah, there's no right or wrong. There's just different combinations.
Right. Excellent. So here's a good one. Regarding the comparison where the cross-lam DLT performed significantly better than other walls with the same R value, is there a report available for that?
There is a report available, or I have a report, but I'm not able to share, and it's from Europe. And that's exactly, I also pointed that out. That's why why we actually having some testing being done in Ottawa next spring to kind of make sure that we can prove the same results. And we also have a wall that actually compares a 6-inch stacked DLT with wood fiber insulation to a 6-inch cross-laminated DLT with the wood fiber insulation to really see the difference there.
Okay,
fantastic. But unfortunately, no data yet. Hopefully by mid next year, hopefully we have the data that we can talk about that more.
Fair enough. Okay, back into the moisture questions. Tim had a comment there saying that so there's no black mold issues.
As far as I don't know, I know there's no mold issues, and I actually know there's one or two of the European manufacturers, they actually guarantee a 50-year no mold guarantee. So and that's based on the fact that the moisture can just freely travel within that wall structure.
Yeah, excellent. That's almost similar to the use of wood in pools as well, where they don't need to have as much HVAC units running through, just because the wood itself, the material, is able to accept moisture and release it.
And same thing, it's never get trapped, right? Because that's the beauty of it. It just can be passed on, and even technically, if you would have condensation within the wood will absorb it right away. So you technically don't really get the condensation.
Yeah. Okay. So in low humidity, like Alberta, in January, can the dowels become loose?
I don't think that the dowels can get loose because they were bone dry when we put them in, so they're never gonna be bone dry again.
Okay, excellent. And one more question, and we'll see what your thoughts are on this. And it's back to the fire. So after a fire event, can a panel be repaired in the field, or does it need to be fully replaced? I guess your thoughts on that.
I guess, like any building, even if it's another prefabricated building, it would be hard to just replace one unit, right? Unless it's kind of curtain wall system where you could literally just lift something off and replace it. But yeah, I'm not quite sure. It would, all the details, how it's fastened, how they're connected to other stuff would need to be considered.
Right. Okay.
I think the biggest point with the fire is just that even if you have a full burn, that they will be safe, right? They will not just collapse. They will be still structural, even if there's a full burn. And also, when you saw with that solid wood member, even if you have a full burn in one unit down below, that the unit above is still safe, and people don't suffer any consequences. So even if the one panel is burned down and charred, you can always clean it off and then just put some framing over top to cover it up, right? But at least I think you don't have to rip down the whole house because it's still structurally solid.
Yeah. Okay. Excellent. So for locations that get a lot of rain, like Vancouver, you don't see that really being a problem, do you? For your panels?
For the panels, when the house is finished or during construction?
Well, I would say both. So what are your thoughts on both?
On both, yeah, we try to make sure that all our panels are having a raincoat on when we install it. And there's some really good membranes nowadays that you can just leave on, that they are actually vapor permeable, that are but watertight. So yeah, we want to make sure, and then also they are actually also anti-slip, so that when people actually walk on it, that they don't fall in a rain situation. Definitely during construction, it is important that you pay attention to rain and water, that those panels stay as dry as possible.
Excellent. Good stuff. One other question. Can you make panels completely out of cedar? or would you?
There's no reason why not. The only thing is it's just, again, if you use it as a structural panel for a ceiling, for example, you will just need larger cross sections to get the same structural value that you get with a Douglas fir or with a spruce panel.
Yeah,
but it's possible. And then again, it's cost again too, right? Like a cedar product will be quite a bit more expensive than a Douglas fir.
Yeah, you'd probably want to use it more as an aesthetic layer or a sacrificial layer of some sort, right?
Exactly. For example, if you have a cross-laminated DLT, that's just as a visible layer. But if you have a stacked DLT to do the whole panel, I think it would be quite expensive. But it's not it's not something we wouldn't do if somebody's willing to pay for it. So
fair enough. Excellent. Well, I think we have. I think we've exhausted all the questions. There's lots of comments. Thank you. Kirk has said he's a DLT convert and would like to use it as much as possible. And again, lots of thanks for the presentation.